Good day, everyone. Today, we want to discuss a topic in physics. The topic we want to discuss is no other topic but circular motion. Um, Most students, they find circular motion difficult, just the way they find circle theory difficult in mathematics. But today, I'm here to make this thing to be as simple as what possible. So follow me so that you see how it can be what discussed. Let's go. All right. When you hear circular motion, just like the name goes, circular. So something that is moving in a circular direction like this. Can you see it? Something like this. Can you see it? Something of this nature moving like this. Can you see it moving like this? Rotating like this. So when you have an object that is moving in a circular direction, we say that it is in what? Circular motion. For example, we have our standing fan. It is rotating. Is it clear? Aha. So this is what? A typical example of what? Circular motion. We even have this earth. Earth is also what? Rotating in what? A circular motion. All right. We have even the minute hand of a clock rotating in what? Clockwise direction. That is circular motion. Is it clear? And so many other things that can rotate. Even somebody that is riding a motorcycle may decide to ride around a circle. Is it clear? It is still what? A circular motion. So when a body is rotating in a circular path, that object is said to be in what? Circular motion. All right. You notice that if a body is moving at constant speed, assuming that a body is moving in a circular path at constant what? Speed. All right. Remember, we say constant what? Speed. Constant speed. All right. When you say constant speed, what does it mean? It means that the speed does not what? Change. It will remain the same thing. Maybe 5 meters per second. That is what the person will be maintaining, rotating around like the clock, the minute hand of your clock. It does not increase the speed. It will maintain it. Can you see? That is what? Constant speed. Is it clear? Aha. So if a body keeps on rotating at a constant speed, is it clear? You notice that acceleration will occur. Why will acceleration occur? Acceleration on a very good day is not supposed to occur to some people because they'll say, acceleration is what? When there is change. Is it clear? But when you say constant speed, this object is not changing the speed. So why the acceleration? All right. Acceleration has to do with what? Magnitude and direction, because acceleration is what? A vector quantity. Is it clear? When there is a change in magnitude, there will be what? Acceleration. Likewise, when there is a change in what? Direction, there will be what? Acceleration. So if a body is rotating, you notice that although this object is rotating at constant speed, but it changes its direction at every moment. Can you see that? The direction here is keep on changing like this. Can you see it? You notice that as this object is rotating, frequently it will be changing its what? Direction. So when you have change in magnitude, there will be what? Acceleration. When you also have change in direction, there will also be what? Acceleration. So acceleration is not only when you have change in magnitude, it can also be as a result of change in what? Direction. So a body that is at constant speed rotating or moving in circular motion is experiencing what? Acceleration. Can you see? Because of what? Because that it changes its direction. Can you see that? All right. And if a body is rotating like this acceleration is acting towards what? The center of the circle. This direction, and this acceleration is acting what? Towards this center of a circle. It is acting towards the center of a circle. That's why it will keep on what? Rotating. All right. So this acceleration that is acting towards the center of a circle, we can express it mathematically by saying that acceleration is equal to, we can say that acceleration is equal to v raised to the power 2 over r, where what? Where v is equals to what? Speed. Where v is equals to what? Speed. We have v to be speed of the object, and r is what? R is the radius. R is the radius of what? The circle. Radius of the circle. Can you see that? Radius of the circle. All right, we have it like this, radius of the circle. Is it clear? All right, then there is another thing we call what? Force. All right, so for this object to be rotating, for an object to be rotating around a circle without moving it either out of the circle or inside the circle, that object must be maintained by what we call what? Centripetal force. It is the centripetal force that will keep this object to keep on what? Rotating. If you are riding a bicycle and you are rotating around a circle, for you to keep on doing that, you must create what we have. You must create what we call what? Centripetal force. As long as the centripetal force is not created, that object will leave that circular track. Either it will skid like this away, or it will go inside. Mostly it will skid away. Because of what? Centripetal force is what? Is felt to what? Be created. So centripetal force is this force that will make you to be retained on that circular track. Is it clear? So this force, remember what we say, that force is equal to mass times what? Acceleration. Mass times what? Acceleration. So this centripetal force, we call it centripetal force. Centripetal force is denoted by what? F. And this F is equals to what? Mass times acceleration. Can you see that? Mass times what? Acceleration. All right, so the centripetal force, like we have here, it means what? Mass times what? Acceleration. But we already have the acceleration to be this. So we have mass times what? We have v raised to the power 2 over what? R. Can you see that? So it means that when you multiply this, you are going to have something like this. So look at the formula that we can use to find what? The centripetal force. We have like this. Is it clear? We have it like this. Where what? Where v is equals to the speed, m is equals to mass of the object. Can you see? Mass of the object. Is it clear? Then r is equals to what? Radius of the circle in question. Is it clear? Radius of circle. Is it clear? So that is how it can be solved. All right, sometimes you hear of centripetal force, or sometimes you hear of what? Centrifugal force. And sometimes people get confused. They misplace centripetal force and the centrifugal force. You need to know that centripetal force and centrifugal force, they are not the same, but they are two forces that are of the same magnitude but in opposite direction. All right, so if you have centripetal force and you are asked to find the value of centrifugal force, they will be what? The same thing in magnitude, but unlike centripetal force that is acting towards the center of the circle, centripetal force is acting towards the center. Centrifugal force is acting away from the center in opposite direction to what? The centripetal force. So centripetal force and centrifugal force, they are equal in magnitude but opposite in direction. So if you are asked to calculate centrifugal force, the answer should be what? It should be equal to the value of what? Centripetal force, but it should be in opposite direction to what? Centripetal force. Centrifugal force is equal in magnitude as what? Centripetal force, but in opposite direction to what? Centripetal force. So that is it. All right, today I want us to calculate a lot of things that has to do with what? Circular motion. I want us to start by finding what is angular distance, angular velocity or angular speed, angular acceleration, and so on and so forth. So follow me, let us do it together. All right, we want to talk about what? Angular speed. When you hear angular, what does it mean? It simply means that this object is in what? In circular motion. Okay, if it is in linear motion, you have linear speed. angular speed, circular motion, linear speed, linear motion. We have angular distance and we have linear distance. So the difference between angular and linear is just that the angular has to do with what? Circular motion, while the linear has to do with what? Linear motion. All right. So when you have angular speed can be denoted by what? The omega. Some people, they say that it's W, it's not W, we call it omega. All right. So omega, we have angular distance over time, just like the way we have speed should be what? Distance over what? Time. If you're talking about linear speed, the formula is what? Linear distance over what? Time. Is it not? Linear distance over time. Likewise, if you are talking about angular what? Speed, it should be what? Angular distance over what? Time. So this theta is what? Angular distance. Of course, t is time anywhere. Okay. So this omega, we call it what? Angular speed. We call omega, we call it angular speed. Can you see that? Angular speed. All right. Then this one, theta, we call it what? We call it angular distance. Can you see that? Angular distance, or you may call it angular displacement, whichever one. Angular distance or angular displacement. All right. So t is what? Is equals to time. All right. But we notice that the unit of angular distance is in what? Is radian. We have it to be in radian. Can you see that? Radian. Is it clear? The unit of time, we have it to be in what? Seconds. We have it to be in seconds. While the unit of angular speed, we have it to be radian per second. Radian per second. Can you see it? Remember the unit of linear speed, we have it to be what? Meter per second. For this one, angular speed, we have it to be what? Radian, because of what? The unit of angular displacement or angular distance. I will call it angular displacement. The unit of angular displacement is what? Radian. So remember, it is radian, that is angular displacement over time will give you what? Angular speed. So unit of angular displacement over unit of time, that will give you the unit of what? Angular speed, which is what? Radian per second. All right, so let us move ahead. All right, like we said, we have linear speed. This is what? S over what? T. Okay, linear speed is equals to this. We have V to be what? Linear speed. Can you see that? Linear speed. And we have S to be what? Linear displacement or linear distance. Let me say linear displacement. If it's displacement, that means you're talking about velocity. Okay. Or it may also be distance, depending. Then T, we have it to be what? Time, like this. Can you see that? Aha. Let me go with our distance. I prefer distance. As long as this one I'm talking about speed, let me use distance. All right. Linear distance. All right. So you notice that the linear speed is equals to S over T, but angular speed is equals to theta over what? T. All right. So we have T here. We have T here. The only difference is that this one has S and this one has what? Theta. All right. So do we have relationship between linear speed and what? Angular speed? The answer is what? Yes, we have relationship. The relationship is that linear speed is equals to angular speed times what? Times radius of the circle in question. Can you see that? Linear speed is equals to angular speed times what? Radius in question. Is it clear? Radius of that circle. Meaning that this for linear speed to be equals to this, you have to multiply this by what? Radius. All right. The linear speed is equals the angular speed is equals to theta over what? T. That means that when you multiply it by r, it will give you what? Linear speed. Is it clear? That means that linear speed v is equals to theta r over what? Over this. Is it clear? Right. That is the relationship between what? Between the linear speed and what? Angular speed. That means that linear speed Linear speed is equal to angular speed. Can you see it? Angular speed times what? Times radius. Can you see that? Angular speed times what? Radius. That will give you what? The linear speed. That is the relationship between these. When you multiply the angular speed by what? Radius, you will get what? Linear speed. Likewise, here, so likewise, linear displacement displacement is equals to angular displacement times radius. So it simply means that when you multiply the angular displacement by what? Radius, you will get your what? Linear displacement. Look at it here. We have S is equals to, we have R times what? This. Can you see? When you multiply the linear displacement, angular displacement by radius of that circle, you will get what? Linear displacement. So that is the relationship between all these.